All right, so in question 9, we get into one of the next big concepts that we need to understand, and that's acceleration. And acceleration, you may notice, has a little bit more complicated units here on the end. So like here's a velocity, meters per second, and acceleration is meters per second squared. And a lot of times what that's going to indicate is a change in something over time. And literally it ends up being over another set of time units, because of the exponent too. It's a very important concept, and in some cases will make questions a lot more difficult because you've got changing velocities. We can find some shortcuts in questions if something comes to a complete stop, which conveniently is what happens here. And we're also looking at magnitude, means we don't care about the direction, positive or negative, up, down, left, right, east, west. We just want to find basically a number answer. And so one of our definitions, we'll have a few going forward in the class, but one of our definitions is that acceleration can be shown as the change in velocity. So triangle is the Greek letter delta, like a D for difference, just happens to be a Greek letter, and then over change in time. Now, typically change in time is just however long it tells you in the question. We're not reading graphs and finding differences in times. So sometimes the delta is not there, but it's part of the main definition we're using in this one. If we look at it, we can pretty easily plug in some numbers, and conveniently everything's in standard units, so meters and seconds or some combination of those. So thankfully we won't have to convert on this one. But if we look at it, our change in velocity, if the person was driving 64 meters per second and then comes to a complete stop, then think about that. It means they're going to go all the way down to 0 meters per second. So the difference between 64 and 0 is just 64. Again, we're looking at magnitudes. So I don't care about signs or directions. I just want a number. So 64 meters per second is the difference, the change in velocity there. And then the time it took to happen, 0.31 seconds. So a very short period of time there. Okay, and so if we check our units, we've got meters per second. We're going to divide by seconds again. So be very careful. They're not going to cancel each other because they're doing the same thing. They're both being divided with seconds. So they're going to combine, and we get the units that we're looking for. Then as far as evaluating this, we just need to run it through a calculator. 64 divided by 0.31 is apparently 206.45. Again, the s's combine on the bottom, and we get meters per second squared.